In this video, we're gonna talk about simplifying more factorial expressions. So as you can see in this example, simplify 1 over 2 factorial multiplied by n minus 2 factorial plus 3 over 3 factorial multiplied by n plus 1 factorial. Now, we need to remember that whenever we're adding two fractions or subtracting two fractions, we must have common denominator. So my aim here is to find the least common denominator. To do that, I'm gonna write the first fraction and the second one. The numerators, they stay the same, and I look at 2 factorial by itself. I know that 2 factorial can be written as the product of the first two natural numbers, so 1 times 2, which is 2. Then 3 factorial, it's 1 multiplied by 2 multiplied by 3, which is 6. Now, once I'm done with the numbers 2 factorial, 3 factorial, I need to look at n minus 2 factorial and n plus 1 factorial. Now, again, whenever we're working with factorial, I need to look at the largest between these two. So as I said before, if n is a natural number, then n plus 1 is the one that comes after, and then n plus 2, n plus 3, and so on. If I'm going backwards, so the preceding term will be n minus 1, n minus 2, and so on. So comparing n plus 1 to n minus 2, I know that n plus 1 is bigger than n minus 2. So in this case, I'm gonna write the largest between them, so n plus 1 factorial, in terms of the second largest, or the largest between them here, which is n minus 2 factorial. So n plus 1 factorial can be written as n minus 2 factorial, and we keep adding 1 till I reach n plus 1. So n minus 2 plus 1 will be n minus 1. We add 1, we get n. So each time I'm adding 1. We add 1 more and we get n plus 1. Once I reach the same as n plus 1, I stop. So the n plus 1 factorial, I'm gonna rewrite it in this way: n minus 2 factorial multiplied by n minus 1 multiplied by n multiplied by n plus 1 factorial. Now this n minus 2 factorial stays the same. Now let's check what we can do here. If you notice, we have 3 here and 6, so both are divisible by 3. In this case, I divide 3 by 3, I get 1. I divide 6 by 3 and we get 2. So far we have 2 here, 2 here. Great. N minus 2 factorial and minus 2 factorial are the same. Now I can notice that here we have n minus 1 multiplied by n plus 1 as a factor, but it's missing from the first denominator in the first fraction. So what we need to do is to multiply n minus 1 here. We multiply also by n and by n plus 1. If you multiply down in a fraction by a number, you must multiply the upper part also. So when you multiply the denominator by something, you need to multiply with the same thing in the numerator. So I multiply up by n minus 1, by n, and by n plus 1. Now we can notice now we have the same denominator, and in this case the same denominator is 2 multiplied by n minus 2 factorial multiplied by n minus 1 multiplied by n multiplied by n plus 1. And in the numerator we have 1 multiplied by n minus 1 multiplied by n multiplied by n plus 1. I'm gonna rewrite it in order because multiplication is commutative, so we can't swap the numbers and nothing will change. So I will write n multiplied by n minus 1 multiplied by n plus 1. This addition goes here, so plus, and we have the numerator there, which is 1, equals. Now 2 stays 2, and look at this part: n minus 2 factorial multiplied by n minus 1 multiplied by n multiplied by n plus 1 factorial, I can notice it's the same as the one here. But the answer of that is just n plus 1 factorial. Now, going to the numerator, I can distribute n to n minus 1. We get n squared minus n multiplied by n plus 1 plus 1. For sure we can simplify more, and I will write n squared multiplied by n, which is n cubed. N squared multiplied by the 1 will be plus n squared. Then we distribute the negative n to the other one, so minus n multiplied by n, which is minus n squared. Then negative n multiplied by 1, which is negative n plus 1, over 2 multiplied by n plus 1 factorial. Now, n squared with negative n squared, they cancel out, and we still have n cubed minus n plus 1 over 2 multiplied by n plus 1 factorial, and this will be my final answer. Alright, now we're gonna introduce something that is related to factorial notation, which is combinations. Now, talking about combinations, we needed for our lesson here, which is binomial theorem. So how do we denote combinations? NCR. So NCR, or we can write NCR in this way. So C represents the combination, and N is bigger than R. When we're talking about combinations, that is related to probability and statistics. But in this lesson, we need only how to calculate NCR using the rule. Now, the rule for this is n factorial over r factorial multiplied by n minus r factorial. So the combination rule is related to factorial notation. Now, how to simplify an expression that has combination? So let's look at, for example, find the combination of n plus 3 and this is 2. So n plus 3 C2. I will apply the rule by doing the following. So this is my n, this is my r. So we're gonna go back to the rule, which is n factorial. Instead of n, I have n plus 3. So I will write n plus 3 factorial over r factorial, which is 2 factorial in this case, multiplied by n minus r. N minus r, so n in this case is n plus 3, and r is 2, so we write minus 2. And I don't forget the factorial, equals n plus 3 factorial over 2 factorial, and let's simplify this factor. So plus 3 negative 2, we get plus 1. Now, do I stop here? No, we need to simplify. Again, simplifying this, I look at the largest and the second largest, and in this case we have n plus 3 is the largest number we see, n plus 1 is the second largest. So we're gonna rewrite n plus 3 factorial in terms of n plus 1 factorial. We write n plus 3 factorial. This one, I'm gonna remove it and write it in terms of n plus 1 factorial. So we write n plus 1 factorial, and I keep adding 1 till I reach n plus 3. So after n plus 1 plus 1, we get n plus 2, then add one more 1, we get n plus 3. The 2 factorial stays the same, and n plus 1 factorial will be the same. Now, what do we notice? N plus 1 n plus 1 are the same. So n plus 1 factorial with n plus 1 factorial will be cancelled, and my final answer will be n plus 2 n plus 3 over 2 factorial, which is 1 multiplied by 2, and it's only 2. Now we can stop here, or we can distribute the numerator. I'll do another example. So if we're talking about n plus 3 and n minus 2. So we have n plus 3 combination n minus 2. Again, I always go to the main rule, which is n factorial over r factorial multiplied by n minus 3 factorial. I'll write n here, r here, so I know my n, I know what is the r. Let's apply the rule using n plus 3 and n minus 2. So instead of n we have n plus 3, instead of r we have n minus 2, and n minus r will be in this case n plus 3 minus, and here we need to pay attention. So minus r is all of this, n minus 2 I need to keep it in parentheses, equals. Now we don't do anything unless we simplify the big factor in the denominator. So here we have minus n plus 2. So I'll write n plus 3 minus n plus 2 equals n plus 3 factorial over n minus 2 factorial, and here the n minus n will cancel, we get 5 factorial equals. I check here what is the largest and what is the second largest. So n plus 3 is the largest one, n minus 2 is the second largest. Now, let's rewrite n plus 3 factorial in terms of n minus 2 factorial. So n plus 3 will become n minus 2, and I keep adding 1 till I reach n plus 3. So n minus 2 plus 1 will be n minus 1. We add one more 1, and I get n. You can write n in parentheses or without. We add 1, we get n plus 1. We add 1, I get n plus 2. We add 1, and we get n plus 3, and I stop here because I need to reach n plus 3 over n minus 2 factorial multiplied by 5 factorial. Now, as we can notice, n minus 2 factorial with n minus 2 factorial will cancel, and I get on top, I will write it in order, which is n minus 1 multiplied by n plus 1, n plus 2, and n plus 3. No need to expand. If you want to do that, that's totally fine. If you want to write the n at the beginning, that's also totally fine, because as I said, multiplication is commutative. Now 5 factorial 5 factorial means 1 multiplied by 2 by 3 by 4 and by 5, and we can get the answer of that, which is 2 times 3 is 6, and 4 times 5 is 20. 6 times 20 will be 120. And this will be our final answer.